A ray is incident at an angle of incidence I on one surface of a small angle prism with angle of prism A and emerges normally from the opposite surface. If the refractive index of the material of the prism is mu, then the angle of incidence is nearly equal to mu A. The Brewster's angle IB for an interface should be 45 degrees less than IB less than 90 degrees. In Young's double slit experiment, if the separation between coherent sources is halved and the distance of the screen from the coherent source is double, then the fringe width becomes 4 times. Two similar thin equiconvex lenses of focal length of f each are kept coaxially in a contact with each other such that the focal length of the combination is f1. When the space between the two lenses is filled with glycerin, which has the same refractive index is equal to mu is equal to 1.5 as that of glass, then the equivalent focal length is f2. The ratio f1 is to f2 will be 1 is to 2. A convex lens is dipped in a liquid whose refractive index is equal to the refractive index of the lens. Then its focal length will become infinite. Two thin lenses of focal length f1 f2 are in contact and coaxial. The power of the combination is f1 plus f2 by f into f2. For the angle of minimum deviation of a prism to be equal to its refracting angle, the prism must be made of a material whose refractive index lies between 2 and square root 2. A concave mirror of focal length f1 is placed at a distance of d from a convex lens of focal length f2. A beam of light coming from infinity and falling on this convex lens concave mirror combination returns to infinity. The distance d must equal 2 in 2f1 plus f2. A ray of light is incident at an angle of incidence I on one face of a prism of angle A assumed to be small and emerges normally from the opposite face. If the refractive index of prism is mu, the angle of incidence I is nearly to mu A. If focal length of objective lens is increased, then magnifying power of microscope will decrease, but that of telescope will increase. At the first minimum adjacent to the central axiom of a single slit diffraction pattern, the phase difference between the Huygens wavelength from the edge of the slit and the wavelet from the midpoint of the slit is pi radian. For a parallel beam of monochromatic light of wavelength lambda, diffraction is produced by a single slit whose width A is of the order of the wavelength of the light. If d is the distance of the screen from the slit, the width of central maxima will be 2d lambda by A. A plano-convex lens fits exactly into a plano-concave lens. Their plane surfaces are parallel to each other. If lenses are made of different materials of refractive indices mu1 and mu2 and r is the radius of curvature of the curved surface of the lenses, then the focal length of the combination is r by 2 into mu1 plus mu2. In an astronomical telescope, in normal adjustment, a straight black line of length L is drawn on inside part of objective lens. The eyepiece forms a real image of this line. The length of this image is I. The magnification of the telescope is L by I. A parallel beam of light of wavelength lambda is incident normally on a narrow slit. A diffraction pattern formed on a screen placed perpendicular to the direction of the incident beam. at the second minimum of the diffraction pattern. The phase difference between the rays from the two edges of slit is 4 pi. The interference pattern is obtained with two coherent light sources of intensity ratio n. In the interference pattern, the ratio is will be ratio I maximum minus I minimum by I max plus I minimum will be 2 root n by n plus 1. A beam of light from a source L is incident normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back as a spot on the scale placed just above the source L. When the mirror is rotated through a small angle theta, the spot of the light is found to move through a distance y on the scale. The angle theta is given by y by 2x. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of large focal length and large diameter. Unpolarized light is incident from air on a plane surface of a material of refractive index mu. At a particular angle of incidence I, it is found that the reflected and refracted rays are perpendicular to each other. Which of the following option is correct for this situation? Answer is reflected light is polarized with its electric vector perpendicular to the plane of incidence. In total internal reflection, when the angle of incidence is equal to the critical angle for the pair of media in contact, what will be angle of refraction? 90 degrees. Rainbow is formed on the opposite side of sun's position.